Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so in this video, I choose 4 questions, if I'm not mistaken, then for our discussion on how helping the students and helping all of you to begin understood the on how to answer the question of number system. We call past year questions based on topic 1, number system. Okay, most of the questions mostly the question of complex numbers, but maybe the question of index and cert you can meet in other topics. It's okay. So without wasting so much time, before that, if you don't mind, can you please click the button subscribe, like, share and bell button to support my channel, and hopefully it motivate me to create more videos to help all of you and your friends. Okay, if you don't mind. Okay, so these are all questions that I chose for today's video. Okay, but for this question number 2, I think that we focusing on question of B. Okay, never mind. Okay, the first question given here, there are 2 complex numbers of Z1 equal to 5 plus 3i and Z2 equal to 2 minus i. So state Z1 bar and Z2 bar. So first question here, Z1 bar or Z1 star is a conjugate. So the conjugate of these two, well, easy. 5 minus 3i and Z2 bar equal to 2 plus i. That's it. Question B, determine the value of K if 1 over Z1 equal to K and Z1 bar. Okay, so for this question, we substitute the value of the equation of Z1, which is 5 plus 3i, and Z1 bar, 5 minus 3i, 1 divided by 5 plus 3i equal to K, and then 5 minus 3i. Okay, so then class, for this one here, just imagine that if we divide by 5 minus 3i on right side and also divide by 5 minus 3i on the other side. Okay, so then let's say this one here, divide by 5 minus 3i, or make it like this one here. Okay, multiply with 1 over 5 minus 3i, and also multiply with 1 over 5 minus 3i. Okay, so this one divided by this itself equal to K. So then K equal to, okay, look at this one here right now. Okay, multiply this one, multiply with 1 over 5 minus 3i. So then 1 times 1 equal to 1. 5 times 5, 25, and these two are conjugate. So 5 times 3i, 15i. 5 times negative 3i, negative 15i. So 15i minus 15i, 0. Okay, and negative times positive, negative. 3 times 3 equal to 9, and I times I squared. And I squared, as you know, is a negative 1 here. Negative times negative, positive. So 1 divided by 25 plus 9, 34. Okay. Find Z1 multiplied with Z2. Hence show that Z1 bar and Z2 bar equal to Z1 and Z2 bar. Okay. For question C, Z1 multiplied with Z2 equal to Okay, so 5 plus 3i and 2 minus I. So 5 times 2, then 5 times negative I minus 5i. 3 times 2 equal to 6i, and positive negative 3i times I, 3i squared, where 3i squared is negative 1 here. So negative times negative, positive. Okay, so 10 plus 3 equal to 13, 6i minus 5i plus I. Okay. This is the first solution for this one here. Find Z1 times Z2. Okay, now Z1 bar multiplied with Z2 bar. Z1 bar multiplied with Z2 bar equal to 5 minus 3i and 2 minus I. Okay, so 5 times 2 equal to 10. 5 times negative I minus 5i, negative 3i times 2 minus 6i, and negative I times negative times negative, positive 3i times I, 3i squared. Okay, so 3 squared, I squared equal to negative 1, negative times positive, negative, so 10 minus 3 equal to 7, and negative 5i times minus negative I minus 11i. Okay class, I think that I make a mistake here. Let me make a correction before we continue. Okay, so then Z1 is Z1 bar is 5 minus 3i, correct? And Z2 bar 2 plus I, there's 2 minus I here. Okay, make a correction here then. Okay, let's try again. 5 times 2 equal to 10. 5 times I plus 5i, negative 3i times 2 minus 6i, and negative 3i times positive I minus 3i squared. Okay, I squared is negative 1, and negative times negative, positive. So then 10 plus 3 equal to 13i. And then 5i, positive 5i minus 6i, so equal to negative I. Okay, now back to the question here. Z1 bar multiplied with Z2 bar equal to, this is Z1 multiplied with Z2. So then Z1 multiplied with Z2 bar equal to 13 minus I. Okay, so again, Z1 bar multiplied with Z2 bar separate. This is equal, and then Z1 multiplied with Z2 bar. So this is, okay, for this one, represented by this, 13i minus I. Okay, 13, sorry, there's no I then. Okay, 13 minus I. And also 13 minus I. So they are equal. Okay, so then next, let's focus on this question B here. I chose the question B, or square root of 6 plus 8i equal to a plus bi. Okay, we are going to eliminate this square root sign. It's a square root sign or power of half. Then we square here, and don't forget that we need to square both left and right. So then clear this. So then 6 plus 8i equal to, expand this. Okay. Squared means that it is a plus bi multiplied with a plus bi. So this term appear twice. Okay. So then A times A squared, A times BI plus A BI, plus with BI times A BI, BI times BI, B squared, I squared. And I squared equal to negative 1. Okay, so negative times positive, negative. So we are going to separate the term without an I, A squared and minus B squared. Then plus with the term with I here and here, I and I, which is AB plus AB, 2ABI. And we compare this one with the question here, 6 plus 8I. Okay, this, okay, A squared minus B squared equal to 6, equation 1. And 8 with the I here equal to 2AB equal to an 8, equation 2. So now class, this is in the form of simultaneous equation, but the difference is it is in the form of A squared minus B squared. There's a sign of plus minus here, but for this one it's multiplied 2AB equal to 8. So we cannot simply using elimination method, no. But it's also it's possible to use the substitution method. So from equation 2, 2AB equal to an 8, then A equal to 8 divided by 2B, which is 8 divided by 2 equal to 4 divided by B. Then assume that this is equation 3. Okay, from equation 2, we divide by 2B left and right, so then A equal to 8 divided by 2B, 8 divided by 2 equal to 4 over B. Then substitute equation 3 into equation 1. Okay, so A equal to 4 divided by B. Equation 1, we have A here. So then A squared minus B squared equal to 6, where A is 4 over B squared minus B squared equal to 6. 4 squared is 16. B squared minus B squared equal to 6. So we are going to multiply this with B squared, multiply with B squared, and multiply with B squared. So B squared divided by B squared, 1. Okay, so what we have here right now, negative B squared times B squared, negative B power 4, negative B bring to this side, become positive. So we got B power of 4. Okay, bring this to the other side. So B power 4 plus 6B squared and 16 positive, bring to the side, become negative, equal to 0. Okay, class, what we have here right now is B power 4 plus 6B squared minus 16. This power of 4 is not quadratic, but then we can use the form, or we call it quadratic pattern, the pattern of quadratic, to solve or find the value of B for this one here. Okay, just imagine that if I change it into x squared minus plus 6x minus 16 equal to 0. Okay, x squared, just compare with B power 4, x compare with B squared here. So then 16 is 1 times 16, 2 times 8, 4 times 4. Okay, so then the difference here is 6. The difference here is 6. 1 with 16, it won't give you the, we call the difference or addition is 4. No. Okay, 16 minus 1 is 15. 1 minus 16, negative 15. 4 times 4 equal to 16, but 4 plus 4 equal to 8, not 6. 4 minus 4 equal to 0, which is also not equal to 6. So this is not it. Okay, so this one left here now, and different is 8 minus 2 equal to 6. Okay, so then x minus 2 and x plus 8. Again, x times x, x squared. X times 8, 8x. Negative 2 times x minus 2x. So 8x minus 2x equal to 6x. Okay, now implement this, our discussion just now, into this question. Okay, but the thing is, this is not b squared. This is b power 4. So we change into b squared and b squared. Okay, and minus 2 plus 8. Again, b squared times b squared, b power 4, b squared times 8, 8b squared, negative 2 times b squared, negative 2b squared. So 8 minus 2 equal to 6b squared. And negative 2 times 8 equal to negative 16. There you go. So it means that here we got b squared minus 2 equal to 0, b squared plus 8 equal to 0, then b squared equal to 2, b squared equal to negative 8. Okay, just substitute any values of b. Just name it. Is it whether positive or negative? But when it comes to b squared, positive value square equal to positive value. And even if b is negative, then negative value square, just like negative 4 square equal to 16, positive. So b squared, it won't give it's impossible, okay, to give us a value of negative something or negative 8. So this one is not the answer. Only for this one, b squared equal to 2, then b equal to plus minus square root of 2. Okay. So then there's two answers here, two set of answers. B equal to plus minus square root of 2. So then when b is square root of 2, then a equal to 4 divided by square root of 2, and when b is negative square root of 2, then a equal to 4 divided by negative square root of 2. Okay, let's say if I multiply this one with negative square root of 2 and square root of 2. Square root of 2 times square root of 2, 2, and 4 square root of 2. 4 divided by 2 equal to 2, which is 2 square root of 2. And what about this one here now? Which I think that the same thing goes here. Okay, multiply with negative square root of 2 and negative square root of 2. Okay, so negative times negative, positive, square root of 2 times square root of 2, 2, and 4, negative square root of 2, then 4 divided by 2 equal to negative 2 square root of 2. Okay, so when b is square root of 2, then a is 2 square root of 2. When b is negative square root of 2, and a negative 2 square root of 2. Okay, next, determine the value of y, x and y if given here class. I think that I'm going to choose question. Okay, let's try if I have a time that we discuss both of this. Okay, 2x plus 12y plus x plus y, I equal to 6 minus 2i. Determine the value of x and y if given here. Okay, 2x plus 12y plus x plus y, I equal to this one here. So 2x plus 12y. Okay. if you realize that, class, if you realize that on this left side is already separated, we call separate the term of real part with this one real part and imaginary part with this imaginary part. So we can simply compare between these two with 2x plus 12y equal to 6, equation 1, and x plus y equation to negative 2. We call equation 2. 2x plus 12y equal to 6 and x plus y equal to negative 2. You can choose substitution method or elimination method. If elimination method, so I do suggest to all of you, we multiply equation 2 with 2. So then come up with 2x plus 2y equal to negative 4. So we may compare between these 2x and 2x. Equation 1 minus equation 3. 2x minus plus 12y equal to 6. 2x plus 2y equal to negative 4. Equation 1 minus equation 3, then 2x minus 2x equal to 0, 12x minus 2x, 10y, 6, negative, can negative become positive, so 6 plus 4 equal to 10, then y equal to 1. So substitute y into equation 3 or equation 2 or equation 1, it's all up to you then. So we call substitute y equal to 1 into an equation 2 because y1 here. So then x plus y equal to 1, then equal to negative 2, then x equal to negative 3. Now, question B, z1 equal to 3 plus 4i, z2 equal to 5 minus 2i. Find z3 in the form of a plus bi with this one here now. So 1 over z3 equal to 1 over z1. z1 is 3 plus 4i plus with 1 over z1 times z2. So 3 plus 4i, 5 minus 2i. Class. There are two options of solving this. First, you expand this 3 times 5 plus and all this, and then 1 over 3 plus 4i plus with 1 over, there will be a new complex numbers appear on this side. You get it? First method is you expand this and simplify. Then you'll find that there will be two fractions here, 1 plus 3 plus 4i plus with 1 over a new complex number that will appear here. Method number 2. Method number 2, I straightly come up with 3 plus 4i multiplied with 5 minus 2i divided by 5 minus 2i. Plus with 1 over 3 plus 4i and 5 minus 2i. Class, don't get confused. Why that there's only, we call 3 plus 4i multiplied with this 5 minus 2i on the denominator side only, but for this one, we multiply with 5 minus 2i top and bottom, above and below. Why? First of all, this one is already been given in the question. This one plus with this. But then, I'm trying to equalize the denominator, this denominator of 3 plus 4i, And this one, 3 plus 4i multiplied with 5 minus 2i. Okay, this is already given in the question, plus with this one. So if I like to equalize the denominator of this with this, so I multiply with 5 minus 2i. But I cannot simply add up with this one on the denominator side only. So I need to come up with also 5 minus 2i on the top of this. Okay, so then right now, look at we call the denominator of both of this. 3 plus 4i multiplied with 5 minus 2i. 3 plus 4i multiplied with 5 minus 2i. They are all equal now, right? Okay, they are equal now. So then 1 times this plus 1. 1 times 5 minus 2i, 5 minus 2i, plus 1. 5 plus 1 equal to 6, or not plus minus. Okay, 5 plus 1 equal to 6 minus 2i divided by, okay, since that the denominators are equal now, so I can simply, so we call count on this one here because the result of this equal to this one. So 3 times 5 equal to 15. 3 times 2i minus negative 2i minus 6i. 4i times 5. 4 times 5 equal to 20i. And positive times negative, negative 4 times 2 equal to 8i squared. Okay, 6 minus 2i. I squared is negative 1. Negative times negative equal to positive. So then 15 plus 8, 23. And 20 minus 6, 14i. Okay. So now, this is not in the form of a plus bi. Wait a minute. This is 1 over z3. Okay. We want it recall in the form, or we want it we call the complex numbers of z3. So means that here, this one you come up with z3 equal to, change the position, switch the position upside down, and you come up with 23 plus 14i divided by 6 minus 2i. So, and come up with the we call conjugate of 6 plus 2i and 6 plus 2i. Okay. So divide by 6, we call divide by this one here, multiply with the conjugate. 6 times 6 equal to 36. Positive and negative cancel each other, then say negative times positive, negative 2 times 2 equal to 4, I times I squared. Okay, so slowly in here, 23 times 6, 23 times 6, 23 times 6, okay, I just got it. 23 times 6, 138. Okay, 138. 23 times 2, 46i. 14 times 6. Okay, 14 times 6, 84 I. And 14 times 2, 28i squared. Okay, so I squared is negative 1, negative times positive, negative. So then 138 minus 28. 110. Okay, 46 plus 84. 130. Divided by, okay, now I squared is negative 1, negative times negative, positive. 36 plus 4, 40. So 110, 130, and 40, which I think that we can divide everything by 10, right? Divide by 10, divide by 10, divide by 10. So then what's left here right now? 11 plus 13i divided by 4. And don't forget that we want it in the form of a plus bi. So this is not we call the final answer yet. It is 11 over 4 plus 3 over 4i. This is in the form of a plus bi. Okay. Solve P and Q where P is not equal to Q. Okay, P is not equal to Q such that this one here, okay, P plus Qi divided by 3i equal to 3 plus square root of negative 16 minus I cubed. Okay, before that, let's take a look at this. This is 3 plus square root of negative 16, which is negative square root of 16 times square root of negative 1. And this is I, right? Okay, so square root of 16 equal to 4i. Okay, so 3 plus 4i minus I cubed. And what about I cubed? I cubed is I squared times I squared equal to negative 1 and I equal to negative I. Okay, so now, wait, 3 plus 4i minus, minus, and I cube itself. I cube is negative I. So, negative I here. Negative times negative positive, so 3 plus 4 plus 1 equal to 5i. Okay, now we compare with the question here, P plus Qi divided by 3i. So let's say if I multiply with 3i on the left side and multiply also with 3i on the other side. So 3i divided by 3i, P plus Qi equal to 3 times 3 equal to 9i plus 5 times 3 equal to 15i times I squared. And I squared is negative 1. So then negative 1 times 15, negative 15 plus 9i. So we compare with this one here, P plus Qi. For real part, P equal to negative 15 and Q, or imaginary part, Q equal to 9. Okay, that's all for today, and I do hope that this video helps you. Recall, at least to find the beginning starting point of solving this question, and please do continue with the rest of the questions inside your tutorial book. That's all for today. Thank you very much, and till we meet again, Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.